Our final video in this module covers data import. So we've explored some R basics and we've learned the data structures that R uses to organize data. Now we're going to learn about how to read in external data files. In the slides, I'm going to quickly cover three main packages and then I'll switch over to our example script. The first package is readr, and this is the primary one that we use in this class simply because the primary data type that we encounter is CSV. readr is used to read in rectangular data, and that means that this data is delimited by things like commas or tabs. So it has a clear or column and row format. It's just that the way that the file structures those is through something like this. So here we see a CSV file. We see that it has variables called student ID, full name, favorite food, and so on. And then each row represents an individual student and those attributes. So, for example, this first student likes strawberry yogurt and their meal plan is lunch only. And the way those individual values are separated is through the comma. Some other formats include CSV2s, which are semicolon separated files, TSVs, those are tab delimited files, and so on. So readr helps us with those sorts of files. The next package is Haven. Haven helps us with files from SAS, from SPSS, and from Stata. So, for example, read underscore DTA helps us read in Stata files. Our final package is read Excel, which is useful for Excel files. So Excel files are structured really similarly to CSVs. The difference is it's not delimited by a comma, but Excel files are often really messy in the sense that there's rows like this that aren't actually data names. There's often things like notes and so on. So Excel files are actually trickier than one might expect. Let's move to our script. So here we see, again, I'm in my 601 projects, which means that I'm in my 601 working directory. I have a clear title at the top. And again, we have some clear headings that help us organize the file. Make sure that as you run through this this script, you uncomment each of these install packages line, so that way you can install the packages you don't have. Since I already have all of these, I'm just going to go ahead and run through the library commands to pull them into my project. So the first package that we're going to work with is here. And here is really helpful when it comes to managing file paths. Using the question mark to look up this package, what here does is it helps you find your files across different subfolders. So for example, here I have my data files in a data folder. I have my example code in my example code folder. Our next package, of course, is readr, and then read Excel and Haven. And then I include NYC flights up here because it's an example of a data set that's built right into R. So as we explored on CRAN, there's tons of different packages. Many of them include built-in data. For example, flights is referenced in your textbook, and this is an excellent data set for tidying data examples. And so flights just records on-time data for flights that departed New York City in 2013. When I want to pull in that data, what I can do is use the data command. And then when I click on view or any other function that interacts with the file, it's pulled into my global environment. So I wrote view, and now we can see here that flights has been read in as a data frame. Another way for you to quickly view a data frame in your global environment is to use the head command, just like this. So what it does is it pulls in the first few rows, and it shows you the data type of each column. So for example, year here is an integer, departure delay is a double, and so on. But you're going to want to pull in data that isn't already in R. Let's say you're working on a project for work or for another class, and you have an external data file. That's where these libraries, the readr, read Excel, and Haven come in handy. First, let me talk about here. So here is something that I use just to keep myself organized amongst my different folders. So I have cars.csv, which you encountered in tutorial 1, here in my data folder. But when I try just reading it in like this, I get an error. It tells me, wait a second, cars.csv doesn't exist in my current working directory. I could fix that by just having the example code script that I'm referencing right now, that I'm running right now, in the same folder as my data. But that gets really messy. By the end of this course, you'll have downloaded a lot of different files, and it's helpful to have some sort of an organization system. So instead, again, here we have the here descriptor. What we can do is use the here function. But it has to be a little bit more specific than including just the file name. So I have file name as cars CSV, and it's still saying, well, DAX601/cars CSV does not exist. And that's because when I go to DAX 601 here, we don't see cars. Cars is in my data folder. So to properly use here, what I can do is just type read CSV here and then data/cars.csv. And that's what I encourage you to do for all of your files. Use here. What here does is it automatically tells R, hey, that DAX 601 file path is the root, and then you supply the subfolders that you're using with DAX 601. And this is something that is a relative file path still, because all of us in this class, we should all have a data subfolder. So that's just a quick tip. When you have multiple folders in your project directory, that's a way to reference across them. Now let's look at read R. As always, we can always type the question mark and pull up what data um, we can find in the help documentation here in the bottom right quadrant. Again, the same thing that I put a screenshot of in our slides. The goal of read R is to help us read in rectangular data. And again, we've already used read CSV right up here. This is probably the most common function that you're going to use to read in data in this class. And you can see there's a lot of arguments. So read CSV is a more specialized version of read delim. Again, a rectangular data that has delimiters. That's what this package is meant for. When we scroll down to read CSV, or excuse me, when we scroll down to the arguments, we can see that there's a few different things that we can play with. So the first argument that we always put in is the file, and that's what we do right here where we have data/cars.csv. That's the file path. And then we can play with the different delimiter types. So when we use read CSV, it knows that it's a comma, but if we wanted to use read delim, we would just specify delim equals comma. And there's a few other things. You can include your own column names, you can select, you could write in your own column types, and so on. What I want us to play with is call select. So here you can select the specific columns that you want to read in. And cars is a good example because cars, when we just read it in CSV, cars has this index column. And it doesn't really help us, right? It doesn't tell us any new information. Just dot, 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 one, and it provides us with a row number. So let's say that we don't want to include that first column. What we can do is include the call select argument. So call select over here listed as an argument under read CSV. And we can select just the columns that we want. So in our case, type, price, and so on. So I have a descriptive name here, just to give you the example, cars without the ID column. And let's see. Now we only have 6 variables. We no longer have that row number column. And we can see up here in our global environment that we went from 54 observations of 7 variables to now we have 54 observations of 6 variables. But let's say cars had, 15 or 20 or 100 different columns. You wouldn't want to go through and type in every single one manually. Instead, what we can do is use a logical operator. So in the last video, I talked to you about the exclamation point. That means not. And so instead of saying, okay, I want to select all of these columns, I can say, I want to select all of the columns that are not this. So here in the original cars, that weird ID column is titled as dot 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 1. I want everything that isn't that. So when I run this code, we get the same thing as no ID, so no ID not, but we've typed a lot less. So again, we read CSV. The first argument is our file path, which we've designated using the here function. And then we use the call select argument to select all but the columns that contain this variable name. Haven is similar, and I won't go too in depth just again because we don't use this very commonly. But in homework 2, I will ask you to read in a DTA file. So here we go. It's the same exact sort of function. And now we see here, again, here would be a good example of you don't want to type in individual column names that you want to include because there's 696 of them. Moving on to Excel. As I said previously, Excels are actually the most complicated file types to read in. And if we refer back to the slides, here we see that we have a few columns that don't make a lot of sense in terms of variable names. So we have reference and then taken from figure 1 of Ni et al. And we don't want that in our data. So if we try just reading in Excel using the read Excel function, what we'll see is that it's a bit messy. So we have the column name is considered a reference instead of that body weight, and then taken from, etc., instead of population size. And then when we look at the data, we see that those numbers were actually read in as characters, and we don't want any of that. So what we can do specifically here is we can use the skip argument to skip that first row. So again, the first argument is always going to be the data frame, or the file path. We're going to skip that first row, and let's see, what does birds skipped look like? We're getting closer. So now our variable names make sense. It's population size, it's that body weight, and also our columns are the right type, which is great. We can also assign our own names. So here we see that this name has a space in it, which as we explored in our last video, we don't really like to have spaces in our variable names. So rather than changing it manually using mutate, which we'll learn about in the next few weeks, we can just read in with our own specified column names. So here what I'm going to do is skip both the first row, which has that note information, as well as the second row, which has the actual names. And we're going to tell it, hey, I want you to read in the names as weight and pop size, because that's going to be easier for us to type. So now we can use Glimpse to look at this. Okay, we see that the column name is now weight and pop size, and they're both doubles. So that's a quick run through on how to read in files. As I said, our primary package that we use would be readr, and our next most common package to read in data is Excel. And we'll get more in depth with Excel examples in our next